Hello, folks. Welcome to Origins. My name's Donn Chapman. It's my privilege to be your host. Origins is a forum where we use the evidence of science to validate the truth of creation. We have a gentleman with us who has helped to dig up some of that scientific evidence that I think is really exciting because it affirms a young Earth as the Bible does. Dr. Larry Vardiman is here with us. Dr. Vardiman, good to have you.
Glad to be here, Don.
Now, you are the coordinator of the RATE group.
Right. The RATE project is radioisotopes in the age of the Earth, and I was kind of the organizer of it and the administrator.
And you had three big conclusions from that.
Right. The conclusions basically revolved around helium diffusion out of zircons in granite, and radiohalos, polonium radiohalos, and the carbon-14 in coal and diamonds.
Now, of those three things, we're doing a show on each of those. Today, we're going to zero in on the halos.
That's right.
Who would have thought we'd be talking about halos? Yours looks nice and straight. How's mine?
You're looking good.
Okay. We're talking about thousands, not billions of years. Your evidence is really challenging what you guys call one of the icons of evolution.
That's right. The long age of the Earth, the billions of years of age for the Earth, is just automatically assumed by the conventional scientific community and our world around us. So it's one of those things that has become an icon of evolution.
There can't be evolution without billions of years. Even to any person, the most avid evolutionist, if you could prove that we didn't have billions of years, evolution's done.
That's right. Evolution is impossible anyway, but most people think it can happen if you got enough time. But if you take away the time aspect, evolution would be understood to not be able to be possible.
And your group's study came up with three things that you think affirm a young Earth and take away that time.
That's exactly right.
And tell us now, the one we want to zero in today is halos. I think that most of our folks don't understand what they are and what they do, so we really need you to teach us.
Right. We're dealing with this issue of thousands of years, which is what the Bible teaches, versus the billions of years that conventional science basically assumes. And in doing that, one of the main pieces of evidence we came up with was the issue of radiohalos, and in particular polonium radiohalos. These are small damaged spots in rock that is produced by the decay of uranium or other radioactive material as it decays to its daughter products. Uranium is the parent product, and it decays into lead and helium, which are the daughter products. And in doing that, it has a whole decay chain along the way, and each time it throws out an alpha particle, which was part of the decay process, it damages the material and leaves evidences. And
when you slice through the rock, even though it's actually a elongated thing, but when you slice through it, it gives the appearance of being a little halo.
That's right. The radioactive material is embedded in granite. Granite is a kind of a white rock with black specks on it. Most everybody's seen it. You go out and pick them up. The little black specks are biotite. It's a kind of a mica, and it peels off. It comes off in layers. Inside of that biotite are little zircons. Now, these are little crystals of zirconium silicate. These little crystals have embedded in them uranium and thorium, which are radioactive. And they throw out these alpha particles as they're decaying to the lead and helium. Those alpha particles spew out in all directions, produce a sphere of damage in the rock, kind of discolorated. If you peel off the mica, you can actually slice through that at different layers, and it forms a ring in that little thin layer of mica that you peeled off. And if you look at it under a microscope, it looks like a ring, or what we call a halo.
Very good.
And some of the particular ones that we're going to talk about today are polonium radiohalos. I might just mention to the young people in the audience that are kind of interested in this, you can actually do this kind of work at home. If you take a piece of granite and you find those black specks on it, and you take a piece of tape, put it on the black speck and peel it off, you'll peel off a few of those little layers of mica. And if you take that then and put it on a microscope slide and put it under a microscope and search around, you'll start finding these little round halos in there. And so our young people quite often enjoy doing that.
Well, I bet some of our homeschoolers will be trying that out soon. Why don't you go to the screen and show us the material you have for us on the halos today.
Okay. We went out in the field to collect samples, and we were collecting granite. We were working primarily with granite in this whole effort. And we collected granite samples from all around the world to be able to have a wide distribution of samples. This is particularly one that maybe some people in the southeastern United States would be familiar with. This is Stone Mountain near Atlanta, and it's made out of granite.
Oh, okay,
so we collected a whole series of granite samples across the top of Stone Mountain. We collected granite from the White Mountains up in New Hampshire. We collected granite from the rocky outcrops in Southern California. And in Australia, Dr. Andrew Snelling, who did most of this work on this project, is from Australia, and he collected a number of samples from Australia. My favorite spot for collecting samples, however, was in Yosemite National Park. And this is Dr. Snelling sitting up above the canyon there, the Yosemite Valley in Yosemite National Park. And I mistakenly accompanied him on this rock collecting expedition, which I would advise your viewers, don't ever become a helper to a geologist, because you end up getting carried all the rocks. You don't see him carrying any rocks.
He's very busy taking notes.
That's right.
Yeah.
Well, we started at the top of Glacier Point in Yosemite National Park, and we hiked down a 6-mile trail down the south side of Yosemite Valley into the valley floor below, collecting rocks along the way. And by the time we got to the bottom, we had about 40 pounds of rocks that I was carrying on my backpack. So I was completely worn out by that. We collected a lot of other rock samples all the way across Yosemite National Park as well. So we have a very good collection of rock from Half Dome and other places. Now I need to tell our viewers that you can't just go into a national park and collect rocks or fossils or pieces of trees and stuff, take home. That's illegal. You can get arrested and you can get fined for it. We had a special collection permit. And even with the collection permit, as we were going down the trail, we had to not collect the samples when there were other people on the trail that could observe us. So it was kind of funny. We were out here in the woods, and Dr. Snelling was my lookout, or I was his lookout, I guess I should say. And we'd wait to make sure there wasn't anybody coming in any particular direction. Then he'd pound on a rock and break off a sample, and we'd stick it in the bag and then continue on down the trail.
Made you look guilty even though you weren't, right?
Right. We had to do it that way because quite often people would get upset, you know, seeing people taking rocks out of the park if they knew the rules.
But you had all the right permits.
That's right. Well, now here's what a polonium halo looks like, or a halo. And these are a little difficult to visualize here, but each one of these are halos, and some of them can be produced by uranium and thorium and polonium, or any radioactive material that would be in the rock. These particular ones are polonium halos. The one on the upper left are uranium halos, and you can tell the difference by them by the number of rings that they have. And they're a little bit fuzzy, but after you've gotten experienced with this, you can begin to tell by the size and the number of rings in the halo which element it has. Each element puts out a different number of rings, so it's kind of like a fingerprint. You can actually identify what kind of an element it is. Now, the interesting thing about these halos is that it takes millions of alpha particles that are emitted from the uranium center or the polonium center or the thorium to produce that damage and to be able to see a visualized ring. But the polonium halo, for example, only has a half-life at most of a few weeks. And in some cases, the different isotopes of polonium have half-lives less than a second.
Oh my.
So it disappears very rapidly. And that's why this is so significant in terms of estimating how long the decay process occurred. It had to happen very, very rapidly. And it had to happen with a lot of decay in a hurry under conditions where it was solid rock and the rock was cool enough. Because if this occurred in magma, the halos won't form because it just gets all distorted. If it's in rock that is too hot, the halos will actually kind of dissolve and go away. So if the rock is 150 degrees centigrade, which is just a little over the boiling point of water, or cooler, then the radiohalos will remain and you can count them. But if that means if it had to happen under those kind of conditions very rapidly, that means that the process had to happen extremely fast, much faster than we observe it today.
So something drastic was happening quickly.
That's right. Now my next diagram here actually will show an animation of this. This is a zircon, kind of a graphic demonstration of a zircon. The alpha particles are coming out in all directions, and they are producing damage in the surrounding biotite. The black surrounding would be like the biotite, and you can see this coloration showing up here, and it shows up in actually a sphere. We're looking at the sphere, and now if you slice through that, you get the rings like we saw in the previous diagram.
Gotcha.
Okay? That's how that process occurs. Now, if you do this actually in a granite rock sample, here's what granite looks like, and we're going to home in on the biotite, and then within the biotite is the zircon producing this damage. It turns out in the process of uranium decaying, it produces polonium. And this polonium itself is radioactive and produces little radiohalos away from the uranium radiohalo. Now the question is, if the polonium radiohalos have such a short half-life and have to emit a tremendous amount of radiation, alpha particles, in such a short period of time, and yet they're at a distance away from the uranium source, its uranium halo, how did that happen so quickly? It had to be very unique conditions. The rock had to have been formed. There had to have been a flow of fluid through the rock to move those little polonium halos a certain distance away from the uranium. Then the polonium had to decay very rapidly to form the halos, and that had to happen all very, very, very rapidly.
Go over those three things again.
Okay, you had the uranium decaying, producing polonium, which had to be moved away from the uranium by hydrothermal fluid moving through the rock, and then it formed another polonium radiohalo at a distance away from the uranium. That whole process had to happen extremely rapidly, and we feel that this is direct, straightforward evidence of accelerated decay. That's why this is so important.
And you know, when you mention the water, it makes me wonder, are you thinking of a historical event when this would have happened?
Yes, we believe that this actually happened during the Genesis flood.
Sure.
That there was a tremendous amount of heat, there was a tremendous upheaval, the formation of granites all around the globe, and that these also had water flowing through them associated with the flood and the movement of water through rocks. And then the sudden cooling, it had to go from a magma to solid rock to cool rock with fluid through it in a matter of less than a year.
Yeah.
And this whole process would have allowed polonium radiohalos to occur.
That's fascinating.
Now, I need to say that the one who did a lot of analysis on it was a fellow by the name of Dr. Robert Gentry. And he believed that this was a signature of God's creative event at creation. And we believe that too, that these were formed at creation. But we now have evidence that this occurred during the Genesis flood as well. And we'll talk about that in the next slide here. So there was actually two events that we now have very good evidence for, that God intervened directly in the affairs of the earth, the geology of the earth, to produce these catastrophic processes supernaturally, both at the creation and at the flood. And of course, he's intervened in other places according to the scripture as well. But we have direct evidence here now, seeing almost the fingerprint of God, as Dr. Gentry called his book about this.
The fingerprint of God.
Yes.
Doesn't just happen in everyday circumstances.
No, it doesn't happen today.
Yes.
It can happen in very limited locations under extreme conditions, but it doesn't happen globally like we have evidence for here.
Right.
The next slide here allows us to try to identify this with the flood a little bit, these productions of radiohalos. This is a diagram on the left. You see the vertical scale here that shows the number of radiohalos per slide that we took. In other words, you take this tape that has the little mica on it and you put it under your microscope and you find the number of radiohalos per slide, the number of those from 0 up to over 60. Along the bottom is the conventional age scale in millions of years, all the way from 0 to 3,000 million years. That's 3 billion years in conventional time. And we found, with the rocks dated according to conventional time scales, we found polonium radiohalos in all those rocks, but we found a peak in that occurrence at about 300 to 400 million years ago, according to the conventional scale. Well, it turns out those rocks that are dated conventionally at about 300 or 400 million years ago are at the bottom of the sedimentary layer. That is, the layers that were laid down by the flood. Okay. If you go to Grand Canyon, you look over the edge, you see all these layers across Grand Canyon. Those have been laid down by the flood. At the bottom of that layer are the rocks that have this kind of an age, 300 to 400 million years. And that's where the peak in the number of polonium radiohalos occurred. So we identify this process with the flood. That's why we believe that this occurred at the time of the flood as well.
Now, just so our people understand, you don't really believe that was 400 million years ago. You're just using their scale to give you these layers to show where it was.
Right. We have to be able to use the language of the conventional community
Right.
to talk with the
That's right.
with the conventional scientists, plus among ourselves as well. We have some alternative methods and tables that we look at it, but we use their time frame and their terminology in order to be able to talk the same language.
Dr. Vardiman, we have to take a break, but when we come back, I want to discuss with you the significance of these discoveries. We'll be right back. Don't you go away.
Creation versus evolution. You weigh the evidence. The fossil record, a rapid burial. The Earth is covered with layers of sedimentary rock, much of it containing microscopic fossils such as plankton, pollen, and spores. The visible fossil record consists mainly of marine creatures, including clams, jellyfish, and coral. They are found primarily on continents and mountains, rarely in deep ocean basins. The fossil record is strong evidence for the sudden appearance of life by creation, followed by rapid burial during a global flood. Today's guest on Origins, Dr. Larry Vardiman, is chairman of the Department of Astrogeophysics at the Institute for Creation Research's Graduate School. Through his ongoing research in atmospheric science, Dr. Vardiman has contributed much to the field of creation science. He also led the RATE team, a research project examining the age of the Earth. This has been documented in the DVD Thousands, Not Billions. For more information, contact the Institute for Creation Research, 1806 Royal Lane, Dallas, Texas, 75229, or call 1-800-337-0375, or visit the website www.icr.org.
We're back with Dr. Vardiman talking about halos that are found in rock, and the significance that they hold to the young Earth. So, Dr. Vardiman, do I hear you saying that these polonium halos show that there is accelerated decay?
Yes, they're direct evidence for accelerated decay, very much like the helium that we found still resident in the zircons. That's a kind of a smoking gun, you might say. And so is the carbon-14, and we're going to talk about in another program. That's direct evidence that's still existent in the rock, that there was a lot of decay and it happened a short time ago. The same thing with polonium halos. We're actually able to go a little further with polonium halos, and because they had such a short half-life, they had to have happened very rapidly, and because they are at a distance away from their parent, which is the uranium halos, they had to have moved there, and that had to have happened in order of milliseconds and at most a few weeks. And for the rock to cool down from magma, because granite comes from a molten rock, to cool down to become a solid rock and to cool below 150 degrees so that the halos will remain, that all had to happen in a very short period of time. That talks about processes that happen much more energetically and faster than anything we observe today. And that's one of the strongest bases for accelerated decay, as we call it.
And you're saying that the one time in the history of the world when the climate and when everything was just right to do that was the worldwide flood.
Right. I believe that it happened not only at the flood, it also happened in creation, because that was a special circumstance that God had his hand directly on it and was causing supernatural process, but it also happened during the flood. Now, if Noah and his family hadn't been protected from all that was going on the rocks of the earth by all that water covering it, they would have been probably irradiated by all this that was going on.
So underneath the water there was incredible heat.
Incredible amounts of heat, catastrophic processes, mountain building, separation of continents, and accelerated decay. All of this was going on. It was really dynamic.
Yeah, we just think of the water going up, but there's a whole lot more going on than that.
Now, this accelerated decay is very controversial, and it's hard for all of us to really grasp the implications of that. We presented this information to a science conference in San Francisco in 2003 at the American Geophysical Union, and we had a number of specialists, they're called geochronologists, who came by and discussed this with us, and they were basically amazed at what we had. they were complimentary in that the quality of the research that they were seeing and encouraged us to do more of it, but they couldn't explain it. They didn't want to accept our explanation of accelerated decay by God's direct intervention. It has to all be naturalistic from a scientist, conventional scientist perspective, but they couldn't explain it another way.
So we're kind of at the beginning. Again, we've kind of opened a new playing field in the whole debate, haven't we?
That's right. This is a whole new approach to things, and it's really exciting.
And obviously, at some point, the evolutionists are going to have to deal with this evidence. They can't just ignore it forever, can they?
No, I don't think they can. In fact, I don't think they are. We've had evidence that there are a number of scientists, some of which were at that meeting in San Francisco, who are now doing this kind of research in their own labs, trying to figure out what we've discovered and try to explain it in another way. I know, for example, that the National Science Foundation is now funding research on accelerated decay. So it's really exciting.
And there's a pragmatic reason for that too, isn't there? It just isn't for this debate, but there's a desire that folks would have in finding out if we could cause accelerated decay, isn't there?
Right. Many of these proposals that are funded by the National Science Foundation have at their basis a method for trying to be able to get rid of nuclear waste. If you have radioactive material and you can speed up the process, you don't want to speed it up so it explodes like a bomb, but speed it up, you can get rid of it a lot faster and you don't have to store it for thousands of years. So there's a real a monetary reason for doing this kind of research as well.
Isn't that exciting? Wouldn't it be something that because we were doing research, your research kicks off spending of millions and millions of dollars. I don't talk about billions and billions of years, but I do. I've been around the government long enough to talk about millions and millions of dollars. That research to get rid of nuclear waste would validate the theory that of a young Earth. Wouldn't that be wonderful?
That is great. In fact, we don't have the resources, either manpower-wise or financially, to do the kind of research that is done in the conventional community. So we rely a lot on research that other scientists who are doing that are not creationists, but we use their research results, and at this point, we're excited about seeing some of them base some of their research on the findings that we've had.
That's tremendous. This is exciting. Now listen, if folks want to know more about this, you have a couple of books, one at the academic level and one at more the layman level. Will you tell us about those?
Right. Our premier book is the technical book called Radioisotopes in the Age of the Earth. It's about an 800-page textbook. You have a copy of it there, Donn.
It's a heavy book.
It weighs about 2 pounds. We call it our doorstop.
It's a great book.
At any rate, this is a book that's appropriate for a scientist or someone who has a very strong technical background. I would encourage many people to purchase it, but it's for the scientist type. There is also another book that we've done. It's a paperback, about 200 pages in volume, called Thousands, Not Billions, and it's written for the general public. Now, you still have to have a little bit of technical background, but it allows a person who doesn't have all that training to at least get the basic ideas down and to be able to understand it a little bit more than they would otherwise.
Dr. Vardiman, I again want to thank you for having the foresight and the vision to pull together this group of eminent scientists who gave 8 years of their life to the study that has brought these 3 dynamic conclusions which are really transforming the whole date of the Earth debate. You've given us a great service. We're very, very grateful. And I'm excited to see what God's going to do.
We're grateful to God for providing it for us.
Folks, I bet today, after hearing this show, when you hear the word halo, it's going to have a whole different image for you than it's ever had. It's not the halos in the outfield, it's the halos in the rocks that validate that we have a young Earth that God made. Don't be swayed by the evolutionists who want to just say there's billions of years because we said so. God has said He made a young Earth, and He made it for us because He loved us. We always remember it's God's view that He created you, and that should be your worldview too. So God bless you till you're with us next time.
Thank you for watching this edition of Origins. If If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 814 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins Program number 814, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.